Today we're going to look at how to use conversion factors to solve problems. So first of all, we should know what a conversion factor is. Basically, a conversion factor is going to be two or more measurements that have different units but are equivalent. So for example, if I have 1 foot, I know that's equivalent to 12 inches. That would be a conversion factor because I have two different measurements and different units, but they are equivalent in their values. So if you have equivalent values like this, you can use them in fraction form to solve various types of problems. So let's say, for example, I have 250 inches, and I want to find out how many feet that is. So I can use this conversion factor. I'm going to take my 250 inches, and then I can express my conversion factor up here in a fraction so that I can get rid of the inch unit and solve for the feet units by putting it in a fraction. So I'm going to put what I'm looking for on the top, which will be the feet. And since it's 1 foot is equivalent, 12 inches on the bottom. This is like multiplying by 1 basically. And then the rest now is doing the math. So I'll take the 250 divided by the 12, and of course it helps if you turn the calculator on. So 250 divided by 12, and I'm going to get the 20.83. So that's going to tell me that there are 20.83 feet in 250 inches. So that's just a real basic conversion. These are English conversions. So you can do English conversions, metric conversions. You can do square units, which will be area units. You can do cube units, which will be volume units. So we'll kind of work through some of the different ones, but I'm going to work through the practice problems on chapters 1 and 2 first, and then if you have additional questions, I'll be happy to look at it with you. So let's look at number 5 on this handout. I'm going to turn it this way, maybe you can see better. It says the speed of light in a vacuum is this many meters per second. So what I want to do is I want to find the speed in kilometers per hour. So I'm going to start off with the 2.998 times 10 to the 8 meters squared. I'm going to put it up here. Do my work down here. So I have 2.998 times 10 to the 8th, and this is meters per second. So I'm going to put my second on the bottom, and if it helps just to kind of put a little 1 down there, that might make it a little bit easier, because what you got to make sure when you complete this is that your meter unit is on the top and your second unit is on the bottom. Now I want to go to kilometers per hour. So I need to get my meters to kilometers and my seconds to hours. So those are going to be the conversion factors that I use. So I'm going to start off with what they gave me. Then I'm going to first convert. It doesn't really matter which one of these you do first. I'm going to do the meters first. So you can now go and use your, kilometers. Well, I'll do it down here. Kilometers, and then we have our hectometers, and then we have our decimeters, and then we have our meters, okay? So I'm going to actually move my decimal 1, 2, 3 places to the left, or I can say that in 1 kilometer, there's 1,000 meters. That's a conversion factor. So that's what I'm going to use up here in this problem. Or I could simply just move my decimal over if I wanted to. If I did that, I'd have to take this out of scientific notation. So I'll do that in just a second just to show you. But I'm going to put my 1 kilometer on the top to my 1,000 meters on the bottom. My meter units are going to cancel because they're on, that one's on the top of the fraction, this one's on the bottom of the fraction. So if I solved at this point, I'd be in kilometers per second. Okay. Now, if I do what I mentioned earlier, just by moving the decimal, and I'll do this down here, I got to take this out of scientific notation, so that was in times 10 to the 8. So I'd have to move my decimal in here 8 places to the right. So that would be 1 right there, 2, 3, and then 4, 5, 6, 7, 8. And this would be the same in meters per second. And then if I want to go to kilometers, I'm going to move my decimal 1, 2, 3 places. So this would be 299,800 kilometers per second. If I just wanted to just move the decimal over, okay? So I'm going to show it to you both ways. All right, so once we get to this as our conversion factor, we've got our top unit, what we want. So that's the kilometers. So we got the top unit in kilometers. Now we got to get our seconds. So some conversion factors that we know is we know that there are 60 seconds in 1 minute. And we know there's 60 minutes in 1 hour. And we're going to kilometers per hour, so I'm going to have to use both of those conversion factors. Again, I want to put them so that they're in fraction form. So the first one I'm going to use is this one because I have seconds on the bottom and I want to go to minutes. So I've got my seconds here. So I'm going to put my seconds up here. So my 60 seconds are going to actually go up here to my 1 minute. Second units will cancel. Now I'm in kilometers per minute. And then the last thing I'll do is now I'll take my 60 minutes and go to my 1 hour. Minute units will cancel. So the only units I have left are the units that I'm actually looking for. Then once I get that, all I have to do now is multiply. So I'll multiply this. You can divide it by 1 if you want. Multiply by 1 if you want. Divide by 1,000. Multiply by 60. Divide by 1. Multiply by 60. Divide by 1. Okay? So the rest now is just plugging everything in your calculator. So this number divided by 1,000 times 60 times 60. Does that make sense? And so my final answer should be 0.079 times 10 to the 9 kilometers per hour.